Okay, in today's lecture, we will focus on measuring something which we call as girth, and then we have center lines, and then we have uh, non-symmetrical geometry. Okay, obviously center line is part of geometry, but we are not, we're talking about something which is non-symmetrical, okay, irregular. Okay, so we'll go through them. First of all, the techniques which we will use in this lecture will help you later on to calculate volumes and areas of other quantities. So this is like one dimension which you will use later on to calculate the other dimensions. Okay, so this is like one input in your dimension sheet which you will use multiple times. Okay, so we calculate them one completely, we keep it. So every time I want to use the same thing, I'll just take this value and put it. Okay. So in this lecture, or for measuring girth, center line, and geometry, you must know the principles of geometry. Okay, and they are very simple. Okay, it's not difficult until I get to the last couple of slides. But the rest of the things are very easy. Okay. So you need to understand the geometry of the building first before you go on and start calculating these things. Okay, that's the main point. Okay, then we have something which we call as girth. Okay, and girth can be internal or external. Okay, girth in simple words can mean perimeter. Okay, girth can mean the perimeter. Okay, in simple words, like if you want to just remember it like, but they are different. Perimeter and girth are different. Okay, perimeter is always external, but girth, I told you, can be internal as well as external. Okay, but it's like perimeter. It's like you are taking the perimeter. Okay, the circumference, or so on and so forth. Okay, so when you are booking dimensions, when you are taking of dimensions, one of the most important thing you have to, or you may have to do, is girthing, meaning taking out the perimeter of the area you have. Most of the buildings are designed in square or rectangular blocks. Okay, even the government authorities, when they are dividing the land into blocks, they will divide them square and rectangles, right? Most of them are like this, unless you have some restriction at a particular site. Okay, so it is important that you establish the perimeter length of individual rooms as well as the entire building. Okay, so girthing can be for specific rooms or it can be for the entire building, and most of the times, like they are saying, it will be taking the perimeter of a square or a rectangle. There shouldn't be a problem, right? Okay, we just need to understand the procedure, and that's it. The drawings will show the plan dimensions. The girthing and the center lines are taken from the plan of the building. Okay, so before you start recording or before you start calculating the dimension on dimension paper, it's very important that you establish the girth length. Okay, so you will do some waist calculation for establishing the girth length. And again, what is waist calculation? Yeah, okay. To get the final length, you do some preliminary calculation plus minus something to get the final length. Okay, so one of the most important waist calculation is girthing. Okay, finding out the perimeter. Okay, and this will help you, as I said, later on to calculate many things. One of the example they have given is a skirting in a room. Okay, what is skirting? Nothing to do with girls. Skirting of the room. Yes. What is skirting of the room?
This is
No. What? Yes, listen. Yeah, you were saying something? No? This is this. Okay, the bottom of the wall where you put like half tile for the sake of looks and saving the end of the joint of the wall. Okay. So this skirting is calculated using the girth length. Okay. Which one? Internal, external? Internal. Okay. And then there can be other examples as well. It will be given later on. Okay. So for example, let's say this is a room or this is a plot. Okay. This is a building, whatever. Okay. And you can see the internal dimensions are given. The thickness of the wall is also given. We are not considered about the thickness of the wall right now. Okay, so you can see this internal dimension is 8 and this one is 3. Okay, so if I want to take the perimeter, okay, this wall plus this wall, okay, so 8 plus 3, okay, that will be 11, and then I have the other face as well, right? This is only half, so that's why divide by 2, right? Multiply. Multiply?
Yeah.
Or divide?
No,
Multiply. Everybody sure? Yes. So this is how you calculate the internal girth. Okay, very easy, right? If the figure is always like this. So this is a wall. You want to calculate the plaster of the wall, the paint of the wall. You will always use the same length. Okay. So using this, so when you multiply by 2, it becomes 22 meters. Okay. So this 22 meters is one dimension for the skirting, for this plaster, and for the paint. Right? Okay. So you can see this dimension is used in multiple quantities. Okay, so I don't have to calculate it every time. I will just do it once at the start because I know I will use it again and again. Okay, and maybe you will use it for something else as well. Maybe it's a staircase and you are putting concrete walls. Then it can be the used for calculating the quantity of concrete as well. Okay. Then you look at this one. Okay, so you can see the. So how do I get the internal girth for this one? What do we do?
The words multiply by 2 and the length multiply by 2 and we
Add them together. Okay, this is what they have done there. Okay, so it's a lounge. Okay, one big room, if you want to call it like this. And so the internal this side is 8426, this side 4286. So both of them are multiplied one after another for two faces, right? One end and the other one. Okay, and then you add them together, this is what you get. Okay, now yes. This is waste calculation. This is waste calculation. Okay, once you did this, now you want to calculate the skirting. Now you can see for skirting they have given me what? What is this?
Thickness.
The thickness and the length.
Spacing.
Thickness and
Height.
height. Thickness and height is given, right? So the only thing I need is what?
area. I mean
This is the area, right?
Like
So
that.
area is given. So only thing I need is the length. Okay, and what is my length? The girth. Okay, so once you calculate the girth, then the length of the skirting required is equal to the length of the girth. So this is your waist calculation, and this is your dimension. Got it? This is, repeat. Repeat what?
How to
I was about to do it. You stopped me. This is waist calculation, where you are showing how did you get this 24 something, 25 something. Okay, and this is the dimension now, you are using it. Okay, so waist calculation is how did I get this? This skirting needs length,
Yeah.
and to calculate the length, I need to calculate the perimeter. And how do I calculate the perimeter? This, like this. Okay, so showing how did you get the perimeter is waist calculation. And the perimeter itself will go here in the dimension column, what, right?
Yes.
Dimension column, right? Okay. Similarly, if you want to calculate plaster for the same room. Okay, for the same room, if you want to calculate the plaster is area. Okay, so you need the length and what? Height. Okay, the length is the girth, and then you multiply with the height. Okay, so the same value will be used for calculating skirting, then the same value will be used for calculating area for plaster, and the same value will be used for calculating area of paint as well, right? Okay, and here you see something else which we haven't used earlier. Okay, what do you see in the middle picture? What do you see?
How do we see? What you
What's
doing?
What? Why do I?
So, and the review.
Because I will lose something.
What's in the center of the
Uh-huh.
what's the center bracket?
Okay. Bigger than the preview, right? If I can do this and just why did I go to preview? Yes. Yes.
What's in the center?
What's in the center?
That symbol. That symbol. What's
That's a secret symbol of a very secret society that was made in like centuries ago.
Can we use it?
They call it AND. Epsilon AND. So they are saying this and this. This and this. But they are doing this with something else on the dimension side which we haven't done. Normally we were not doing it like this. What is that? Who was saying bracketing? Yes. What did it do with the bracketing? We discussed bracketing earlier as well. This and this and this, right? Okay. So what is different about this one and the one which we saw earlier? This bracketing and the one which we saw earlier. What's the difference?
Other description.
Huh?
For me, is that
We have two descriptions. So bracketing can be used both in both ways. Two dimensions having same description. Two descriptions on having same dimension. Okay. So they are using it the other way around. Both are allowed. Okay. Anyways, going back to the point, once you have the girth, then you can the internal girth can be used for plaster, skirting, and paintwork, and could be something else as well. Okay, so internal girth is internal perimeter, and the external girth is external perimeter, right? Okay, so if you have a drawing which is only showing the internal dimensions, but you want to calculate the external girth, then what we add is the thickness of the wall, basically. Okay, so the main difference between the internal girth and the external girth is the difference of the wall, and obviously you will add it at each end, right? One thickness here, right? One thickness here, one thickness on the other end. Okay, so this is the only difference between the external and the internal girth. And again, like I showed, you have to show the calculation of external girth or external perimeter and the waist calculations. And there are two ways in which you can do this, calculate the external girth. You should be getting the same value, obviously, but there are just different methods of calculating it. So here they are adding for each corner in method A, so this is the internal girth. 22 is the internal girth. So waist calculation of the internal girth already done. Okay. Now they are adding something to make it external. Okay. What they are adding for each corner, they are adding thickness of, if we have the previous plan, this one is what? What's the shape? Which shape is this? Circle, right? What? Rectangle, right? I need serious people. These people are not serious. Okay. So it's a rectangle, right? Okay. So how many corners we will have? 4 corners. Okay. So 4 for each corner. Okay. And in each corner you have the combination of 2 walls, right? You will add one wall, one thickness, and the other thickness. Okay, this is a corner. I am at the inside edge. I want to get to the outside edge. Okay, from the inside to the outside, I have this wall thickness and this wall thickness. Okay, so that's why 4 for the corners, and every corner 2 walls are meeting. So I add 2. Okay, and what is this? Wall thickness. Clear? So internal girth plus 4 corners into 2 thicknesses of each wall, and so on. Okay. And you have to keep in mind that we are assuming that all walls have the same thickness. Okay, all 4 walls have the same thickness. If it is not true, you have to break it down then. Okay, and in this case, what they are doing is they are taking they are not adding it in the internal girth. They are adding it in each internal dimension. Okay, here 22 was what? Internal girth, right? And they were adding everything in the total number. Okay, here they are not doing it. This is one side of the room, this is the other side of the room. It's a rectangle, right? 2 sides or 2 dimensions. Okay, so this is one dimension, this is the other dimension. Which one? Internal. Okay, and you want to get to the external, so in the internal I will add wall thickness on each side. Okay, so wall thickness on each side, 2 into wall thickness. For one face, 2 into wall thickness, same number, right?
Yes.
For the other face. Okay, so this is the total external for one face, total external for the other face. Okay, and then I will add them together. This will give me one L shape, right? Okay, and I have to multiply by 2 to get the whole room. Clear? Okay, so in method A, you take the total internal girth and you are adding what? 4 was what? 4 corners, 2 walls, right? On each side, on each corner, and thickness. Okay, and you add it in the total internal perimeter once. Okay, this one more detailed, obviously, more steps. You take each internal dimension, add 2 times of thickness in each internal dimension separately. Then you add these 2 dimensions together, they will become one L shape, and then you multiply by 2 to get the total room.
Which one of them you estimate that?
I will not ask any one of them. I just say do it. You can select, no problem. As I said, you should be getting the same number, right?
Does it matter which one?
Yeah, both are allowed. Yeah. Okay, both are allowed. But for your sake, I would say don't mix between them, because you will miss something. Okay, so that's why we say just follow one pattern so you don't miss. Like it becomes a habit, right? And you don't miss.
First one is better.
Huh?
First one is better.
First one is better. Okay. Okay. So for example, you have this one. So the internal girth will be 2 into this dimension and 2 into the other dimension. So 24, 25, 484. This is the internal girth. Okay. If you go with the second method, the first method. Okay. So you will take the total internal dimension plus 4 into 2, 4 corners, 2 thicknesses of each wall. Okay, and you will add it in the internal girth. Okay, clear? Can you check if you are doing the other method, you are getting the same answer or not? Go ahead. So the other method will be what? If I am doing the other one. Okay, what should I do for the other method? What was method B? I just told you. Come on.
Yeah, I didn't focus on it because I was seeing the first one.
Yes.
Repeat that question. Because I like.
Each side and we add it and
Yes.
then multiply.
Okay, come on. So each side 4286. That's why people leave. It's not working. Okay, east side 4286.
Plus
300. Yeah, you should have to keep in mind the units. Okay, these are all millimeters. So fine. So this is how much? 600. How much?
9472.
You are doing the other one? You are doing the long one? No? Okay, for the other side, 8426, same thing. This one, right? You are doing this one. She doesn't even know. Very good. Okay, then this plus this, which is how much now? Yes? Okay. Maybe, I don't know. And then you are not focusing on it, right? Now you are? Okay. And it says how much?
27.
Not 27. 27? 2782. Oh, you are reading it from here. Yes, good. Very smart. Okay, clear? Clear? Okay. Yes, go ahead. Your turn. Yes. Same. They give the same? No. No. I will use 5 font size even in the final exam paper. Wait. Okay, now you can see here the difference in the internal and the external, right? Okay, as how much? 1.6 meters, right? So if I ignored this, if I said fine, it's only 1.6 meters for the entire room, it doesn't make much difference. Okay, how much difference will it make in percentage? If I say internal, external, both are equal. We don't have is wasting our time. There's much other things to do in life. Okay, so if we just ignore the wall thickness, this is the perimeter, take it internal, take it external, same thing. So how much I will lose in percentage?
It's like 9.18%.
9.18%, right? 9%. Okay, and this is only in the length, and this length will be multiplied with something to get the area, right? Okay, so obviously it will increase, and you are just ignoring the thickness of the wall. So that's why we need to be careful about understanding what we are doing, okay, internal or external. Then we have the center lines. Center lines are often used for calculating the quantity of excavation, for calculating the walls, okay, and so on and so forth. So if you have brick walls or other types of walls, you measure them as in square meters, okay, and the length which we take is along the center line. The length which we take is along the center line. So remember in the previous lectures, we have done for excavation, right? We have calculated the quantities of excavation. So the area which you are taking is along the center line. Okay, normally center line of the wall. Okay, so that's why center lines are used there, and we need to calculate the center line as well. They have given some examples here for foundation trenches, for concrete footings, for forming cavities, and so on and so forth. Cavity is like the space between two walls. That is called cavities. Okay, they give it for energy saving. Okay, so you have one wall, then a small gap, then the other wall. Okay, so it has less effect from the outside because of the gap. So that is called cavities. But in all those things, we use the dimension of the center line. Okay, and it's written here for wall insulation, for damp proof cores, which is given at the bottom of the walls. For all these things, we need the center line. What is center line? How do we calculate the quantity of center line or length of center line? Simple. Okay, it's an average of internal and external, right? External is outside, internal is the inside. You want the center, right? So you take the average. Okay, so this is a very simple way of understanding the center line, but simple doesn't work, right? Simple will not give you C and D in the exam, which we want, right? So, for example, if you have internal girth, okay, so, and you want to calculate the center line. So, what we will do in the internal, we will add, right? In the internal, we will add. So, what we will add? 4 for, what was the 4? Corners. 2 for 2 walls. Okay, and half is because we need the center. Okay, it was not half, it was 1 earlier, right? We didn't write 1 because we were going outside. So this is same as calculating external girth, just 1 is replaced by half.
It's one more step.
One more step.
For the
Center line.
center line.
Center line. If you have the external girth, you will do the reverse, right? This is what I was explaining here. If the external is already given, you will do less. Okay, this is how they do less. And you will get the same answer in both cases. Okay, so you see the top plan, the internal dimensions are given. Okay, so if you want to calculate the internal girth, it will be 2 times of one, 2 times the other. You add them together, you get the internal girth, which is 22 meters. Okay, and then you will do this. Each wall is 450 millimeters. Each wall is 450. Total is wall. This is total wall. Okay, so each wall is 450 millimeters. So 4 corners to 2 walls into half of the thickness. Clear? Okay. It's the same, right? Now, what is this? Footing width of, okay. So now we have a footing, okay? We have a trench footing around this room or plot or whatever you call it, okay? So we'll find out the center line, and using the length of the center line, we calculate the quantity of concrete, okay? So you already have internal girth or external girth, whichever one you want to use, okay? So tell me the quantities. First of all, what is the length of the center line? Tell me. If I go with external girth, so I will do 19.6, then less, 4, 2, half. What is the wall?
It's gonna be 18.8.
18 point, no, sorry, how much is this one? 0.8.
0.2. Yeah.
Yeah, the
Okay. 18.8. Okay. So center line is 18.8. Okay. Now concrete. How much concrete? Okay, tell me.
0.4.
Here. And these are the 4 columns, right?
Yes.
Okay, here. So I can write 1 or I can just leave it. There's 1, right? Sorry?
0.6, let's say 0.5. The width and the depth, and then
So, what was order? Anybody remembers? I'm writing the dimensions. What was the order?
-3.
Huh?
3.
3 means?
Length, depth,
Yeah, so which one will go first here?
Length.
Length, right? 18.8 and
width.
0.6 and
0.5.
okay, how much is that?
1.6.
And here you will write the description, okay? And sorry, this should be at the end. Okay, this calculation should be at the end. If this is a dimension sheet, this should be at the end, or this can be at the top, okay? Not in line with this one. And then with this one, you will have the description. Okay, clear? Any problems? Any questions? Okay. Now, we said most of the buildings are regular shapes. Okay? Have you gone to the architecture department? You have gone, or you have come from here? There. What?
After 2.5 years.
See what you are facing now. You're having fun there. Their classes are in front of the coffee shop. What else do you want?
I was in Town.
Huh?
I was in
You
Town.
couldn't wait. Okay. So when you transferred, they shifted here. Okay, but the problem is all plans are not regular shapes. They are not rectangles and squares. They can be irregular plan shapes as well. Okay, so in that case, we need to deal with them. So, for example, here you see an irregular plan shape. Okay, so you see that this is something additional here, which is blocking the, which is not making the rectangle proper.
So we can
Okay.
get full, then we subtract.
Okay, now you look at the right hand side and tell me what will they do. Explain.
They multiply A plus multiply
You
B.
haven't read the 2 seconds rule that yet. I told you. 2 seconds. No? Okay. Go ahead.
A multiply by 2 plus B multiply by 2
And
will give me the external area.
Okay.
External curve.
done.
No.
Finished? No.
We subtract.
We subtract. Okay. I was saying that explain what they have done. You are in your own word. No, I will tell you my thing. So forget about this. Yes, they have done the calculations for the external girth on the slide itself. Okay, so somebody please explain me what they have done.
They deal with it as a regular shape.
And then
And
it's not regular, so what did they do in the end?
Then they add 1,000 and 1,000
Okay, yes.
because it's extra.
yes, so they deal with it as a regular shape, and then they subtract the extra.
They subtract the extra. They subtract it. They
Yes.
are adding. They are adding.
No,
Adding.
as they are taking it as 8 for 100, but
They're adding.
there is no 200.
They are adding. Yeah, so the point is correct. First of all, if you can find a very close regular figure, okay, then you treat it as that close regular figure, which is in this case a rectangle. So you see the first 2 numbers are similar to what we have done for all the rectangular plans. Okay, so 2 into 1 dimension, 2 to the other dimension, you got a number, but this is not the external girth. Okay, because to get the external girth, I have to incorporate what they are calling as re-entrant angles because it's entering, right? So that's why re-entrant. Okay, so you have to see now how much you are going in. Okay, how much you are going in. Okay, so we are going in 1000 and it has two faces, right? Okay, now again what she was saying and what could be a mistake which you may make, that you think I took the whole rectangle and this one is going inside the rectangle, so some part of the rectangle I should be subtracting. It's not area. It's not an area. You don't need to subtract. Okay. When you took the top length, the A value as 8400, this 8400 already has this 2000. Okay. This already has this 2000. So how much extra length? There was another word given in one of the notes. They called it walking through the girth. You walk through the girth. So if I'm walking, okay, so if I walk like this, how much length I will miss in walking? If I'm going like this and go straight like this, I'm missing this one and I'm missing this one as well, right? Okay, so these two should be added. And this is what they are doing here. Okay? Vida? Clear? No. We are calculating length of external girth, right? Okay. So, first of all, we say that this looks very close to a rectangle.
Okay.
This looks close to a rectangle, right? What is the external girth of a rectangle? 2 times this and 2 times that, right?
Yes.
This is what they did here. Done?
Yeah.
But you are missing this 1000 and this 1000, right?
Yes.
So I need to add them. I missed this one, right? Okay. So you will add them now.
Okay.
Okay. And that's it.
That's it.
That's it. Okay. You will not, the point was, because they are going inside, you will not subtract them. Because this is not an area. Clear? Any questions? Clear? Okay. What about this one? What about this one? They calculated this.
They did it as a rectangle.
They did it as a rectangle. First of all, it's a garden wall. It's a garden wall, so it's not ending. It doesn't have a close end. The bottom is not a wall. It's open. Okay, it's finishing at the street or the side of the building, whatever. Okay, but it's not at another wall. It's not another wall. Okay, so what they are doing now? Again, first of all, they say it's very close to a rectangle. Okay, so they calculate the external girth, 2 times of that and 2 times of that. Okay, but the problem is what? As I said, this side, no wall. Okay, so I cannot do 2 times of this. Okay, so 2 times of this, it has walls on both sides, and then plus only the top one. Okay, so this is what you see here. And you can see this 1500 is external to external, right? So this is already external girth. Clear? Now if you want to calculate the, and should I add or subtract anything? External girth, in external girth, okay? Forget about everything else. Is external girth complete? Did I miss anything by doing this? 2 times this, 1 times this. Did I miss anything in terms of length? Nothing is missed in terms of length, right? The length is just going forward and backward, up and down. But the length is still the same. There is nothing extra. Get my point? Previous example, I was going down. There was an extra length, 1000, 1000. In this case, no. If I go from here up to the top, okay, on this side, how much length I will walk? 15,000, right? Some of it here sum of it on this side. But the total is
15,000.
15,000. Okay. Do I need to add something else? No. Okay. If I walk along this path,
2,000.
2,000. Okay. Some of it here, some of it here, some of it here.
Yes.
Okay. So it's broken, but the total is
2,000.
2,000. Okay. If I take the top one as 2,000 and the sides as 15,000, it's done. The total length is done. I'm not missing anything. Got it? Clear? Okay. So since it's an open end, it has an open end, so we didn't do the other side of the horizontal dimension. Okay. So this is external girth. External girth done. For center line, we do what? We are at the external side, right? So for internal, we have to subtract. Oh, sorry, for center line, we have to subtract. Okay. Now, what is the change here? Wall thickness. Because we are talking about center line, so half. Okay. 2 walls on each side. And what is this? 2 corners. Why 2 corners? Why 2 corners?
Because there is one, two, three,
Huh?
four. Because only two corners.
Because only 2 corners. This is what happened to these corners? They are not corners.
Only four walls. One, two.
1, 2. What about these corners? No, they are not corners. They are what? Only wall. Okay. Okay. Makes sense. Okay. If you say the corner is where the 2 walls are intersecting, yes. Okay. Good way to remember it. Okay. If the 2 walls are not intersecting, it's not a corner. Okay. Good. Fair enough. And so this is already, whether you take center line or whether you take external, you will reach this point, right? There is no other wall. There is nothing else ahead. So this is the end of the line. Okay. So corner, you will only take corners where the walls are meeting. Okay. So if the walls are not meeting, then it's not a corner. Okay. So that side will be open, and so for open side we don't need to calculate the corner. So that's why we have 2 corners. Okay. The bottom 2 are not taken. Clear? Clear? Okay. We have to calculate the center line for this plan. The top dimension is 8608 external. The what is this? Left hand side. Left hand side is 6439. Okay, total. And this one, okay, sorry,
3015?
say again,
Is it 3015?
3013 and something else.
Which is the thickness of the wall.
No, it's not the wall. 399, 3013 and 399. How much? 3013, 399. How much total? 3013 plus 399,
3412.
3412. But this is only internal. It's only internal. Okay. Now you need the external girth. Any problem? Can you calculate external girth without any problem? Yes. Okay. How much is it?
26,965.
8608
8608
Plus
64 plus 6439.
how much?
6349, not 6449.
6349.
Yeah.
Hmm.
3412. No, not multiplied by 2.
Why not?
No.
Why not multiply?
You will not take from each side. Because it's already, we considered it
هاي ستة زين بتمشي كيف هاي why is two time doctor
What?
one time right
What one time?
this
What is one time?
it's 6 3 4 9 one time
Why?
because this is not same as the other one
See, okay. This one, and this one. You will consider them this plus this, right? Total will be
Same.
okay
okay. Yes, how much?
2991.
991. Okay. Center line. Two, 9, 9, 1, 4, right? We'll go from external now. Okay.
Yes.
But I need what?
thickness
I know I need the thickness. Okay. For thickness, we need to use these dimensions. Okay. Or the one on the top. Same thing. Okay. So we have 1720, 6392. Okay. 1720 for one room internal. 1720 and 6. Who can read it?
6392.
6392. Okay, these are internal. Okay, I have to add something here to get the full. Okay, how many walls I have to add here? 3 walls, right? So is 3 times x will give me 8608.
why did you
3 walls, right? Yes. One more. So x equals 165.3. Okay? There or not? Any questions? Okay. So now what do we do? Coming back here, what do we do? 4, 2, half. They are writing half like this. Huh? It's all in millimeters, right? So 165. And this is how much? Six, 1.3. And what am I doing here? Is less or adding?
Less.
Less. Because I am going from external to central line. How much is this? 29252.7. Because you already had it in the calculator. From where? Center line. Okay. I have to from the center line for every corner 2 walls half of their width. Okay. So 4 into 2 into half into 165.3 is this one. Okay. Did you get how did we get this one? How did we get 165.3? Okay. Yeah. We have we have the dimension of each room. Okay, and from one corner to the other corner there are 3 walls. So total should be, where is it? Where did I do it? Oh. So one room plus other room plus 3 walls should be total this, the external dimension given. Okay, so each wall equals to this much. Clear? Any questions? What is? Okay. Now we are dealing with L shape and entry angles and a mixture of different rectangles. Sometimes we have this sort of a thing, okay, where you don't see any specific figure, okay, you don't see any specific shape, okay. So in those cases we use what we call as the average method, okay. So we use maybe you have already seen it in surveying. So if you have for example an irregular shaped car park, okay, so there's a car park beside the road and the shape is irregular, it's going up and down and so on. And you have to find out and this is mainly because of the people in architecture, they do these type of things. Engineers don't do this. Who would make a car park like this? Nobody, right? Huh?
We don't
You are not now. Okay, so in that case you go with the average. Okay, so what if you want to calculate the area of this car park for pavement, for marking, for filling, for excavation, for anything, okay, then you can use this simple equation where this one is the average of the distances, okay, and this is the length of the car park, okay. So I have one dimension, you have a look here, maybe it's on that side, yes. So this is the length, okay, so I know the total from here to here is this much, but between this length is not a straight line, it's going up and down, right? Okay, so what we will do for each part, we will take the width for each part and at the end we'll do the average, okay. So for example, if this is my area, okay, so I know I have a problem here, okay, I have a problem with this length, okay, so I will take the length here, 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 so I will have maybe 10 values. So out of these, which one will I take? The average of those 10. Okay, simple? Clear? Okay, so if the shape is too irregular and you cannot make it equal to any regular shape like we did in the previous examples, then you do the average. You break it down into smaller segments and you do the average, okay? And then that average can be used as a representative length, okay? That's what they are saying here. So why we use the average method? Because it is quick and practical, okay? If you have seen, for example, you may have heard this example earlier as well. So this earth is what? What shape? Huh? Like an ellipse, right? Okay. But do we feel like walking on an ellipse? No. Why not?
Because the gradient is very small.
Because what?
Gradient.
Gradient is very small. Never heard of it. Yes. Because why you don't feel it? That I'm walking on a curve, walking a straight path.
Because the area is too big.
Area is too big, right? Okay. So when you take any curve and you divide it into smaller parts, it becomes what? Straight. Okay. So this is the theory behind taking the average method. So it is quick, it is practical, makes sense. Okay. And it is good enough for initial estimates. Very good for initial estimates. If you want later on, when you are giving the contract and you are looking into the exact price, you may go for the exact calculation of the area under the curve. Okay, and you all know how it is done, right?
Integration.
Huh?
Integration.
Integration. Very good. Dr. Sami taught you that, right? Dr. Sami's area. Okay. So for example, we have a curved garden wall and we have taken 4 width measurements. Okay, don't say that we have more measurements in the figure. Figure is just for representation. Okay, so we have a garden wall. This is the boundary of my plot, and within the boundary, an architect came and he will say, I will make my garden like this, up and down, up and down. Okay, so the kids can have fun and keep on banging into the walls. Okay, so on this irregular end they took 4 measurements. Okay, and the 4 measurements are given there. Okay, and we have to calculate the area of this garden, because in the end they will do excavation and they will fill it with the soil which is used for gardening and so on. Okay, so we have to calculate the quantities for landscaping and so on. So how do I calculate the area of this garden? Tell me. What do I do? First of all, we calculate the
total area divided by
total area divided by 4,
multiplied by 10.
multiplied by 10. Total area divided by 4. If I already have the area,
3 plus 5 plus 4, 1, 5 plus 3, 1, 5 over 4.
over 4
Multiply of 10.
multiplied by 10.
The sum?
Even the policeman understands. You don't.
Then what I said
The
that
area.
Okay, no problem. All of you are correct. Don't fight. Okay, so what we are saying is we will take the average of the length, or the average of the width. Sorry, the length is 10 meters and I need the average of the width. Okay, so this will be the area of the garden. Okay, so whenever you have irregular shape, we just take dimensions at different intervals and you just take the average, and that is enough to calculate the whatever quantity you need. So if somebody asks you what is the width of this area, what do you say? What is the width of this area?
We say the area.
What is the width of the area? What is the length and width of this area? This is a garden area, the width, the average of, this is the width of the area. Okay, and this is the length of the area. Okay, so in the end, now why it is important? In some, you have seen, we have the example of a garden wall, right? Your garden wall, if the garden area is like this, the wall will also be like this. And there you will be doing the girthing, right? In girthing you will be dealing with the width and the length separately. Okay? So how do you get the width? We will take that. Okay? If somehow you can make it more or less regular, like a rectangle, we will go what we have done earlier. But if it is too much up and down, you don't have that much time, right? Like maybe one extra semester only, right? Okay. Then we have another very commonly used figure which is called as trapezium. Okay. In many cases you will be facing something, a shape like this. Okay. Especially when you are dealing with earthworks. Okay. Because excavations and road works and things like that, they are not done exactly in vertical alignment. The sides do not go exactly like this. Why? Because this will be unstable, right? Okay. So what we do is we make it sloping. When you make it sloping, you will get a figure like this, right? Okay, and that figure is called a trapezium. Okay. So to calculate the volume of the soil, which you need to take it from here, okay, you will assume a trapezium. Okay, the cross section will be taken as a trapezium, and then you have another thing here on the side which is called as the bell mouth. I don't have an example for that. Where do we use it? I don't know. Okay, but bell mouth is something like this. So what we have done earlier. This is the shape I want. Okay, like a moon, half moon or something. So first of all, I will take this one as a regular shape, a square or something. Okay, square rectangle. Okay. Then this one is part of a circle. Okay. So how do I calculate this area? Tell me. Integration. Very good. I don't know how to.
Pi r square over 4.
Over 4. Why 4?
Because
it's approximate.
Because it's a quadrant, right? Because it's a quadrant. So
As a sector.
as a sector, yes, as a sector. Okay. So then you divide, then you take it one regular shape, then you subtract with a sector, and then you get the remaining area. Okay, so this is again going back to the principle of what we have discussed earlier. Okay. Okay, so take a picture, do this, come back with it next time. Like you should guys have a competition or something, right? Who has the best pictures, right? You guys should share the pictures in the group and there should be some voting or something.